if I am going to have 8 by 1 multiplexer circuit, how many number of 2 by 1 multiplexer circuits are required instead of using 8 by 1 MUX? I hope you understood, right? So instead of implementing any kind of multiplexer with the help of 8 by 1 MUX, can we able to implement with the help of 2 by 1 MUX or not? Yes. Then how many 2 by 1 MUX are required? Right? As I said there, when you are trying to implement with the help of AND OR gates, what might be the problem? How many number of AND gates are required? How many number of OR gates are required? They are going to get confused. Instead, what they did, they generalized it to one kind of gate like NAND, or if it is OR AND, they generalized it to NOR now. Am I right? Yes. So here also same question. If I can able to implement anything with the help of any kind of MUX, but the question is how many 8 by 1 MUX are required? How many 4 by 1 MUX are required? How many 2 by 1 MUX are required? Like that question. So instead, what they can do, they can able to implement with the help of one kind of MUX, so that they can able to use it further. Right? That's the reason I need to find out the solution for it. So if I am going to have 8 by 1 MUX, how many 2 by 1 MUX are required? Can you able to define? Right? I think we have drawn the circuit for that. Right? So if it is 8 by 1 MUX, I can able to implement with the help of 2 by 1 MUX. How many 2 by 1 MUX are required? 7 2 by 1 MUX are required, right? 1, 2, 3, 4, 5, 6 and 7 2 by 1 MUX are required. Similarly, if I am going to have 8 by 1 MUX, how many 4 by 1 MUX are required? How many 4 by 1 MUX are required? Try to observe. How many inputs are there here? 4 inputs are there. These 4 inputs will be given to one multiplexer. These 4 inputs will be given to one multiplexer, 4 by 1. Now with this I am going to get output 1. With this I am going to get output 1. Now again I am going to take one 4 by 1 MUX only. Right? Or I can take 2 by 1 MUX also. There is no problem. But they are asking in terms of 4 by 1 MUX. Here also I will consider 4 by 1 MUX only. What about the remaining 2 positive values? I will make them as zeros. 0, right? So meaning that how many 4 by 1 MUX are required here? 3. How many 2 by 1 MUX are required here? 7. Right? As it is simple one, you can able to derive directly. But if the question is something like how many 1024 by 1 MUX, it's like for implementation of 1024 by 1 MUX, how many 2 by 1 MUX are required? In the exam, are you going to draw the circuit like this? That's a kind of complex thing, right? So can we able to generalize it? That's the question. So for this, I will try to explain. For example, if I am going to have two lines, can I implement one multiplexer? Can one multiplexer of size what? 2 by 1. So in 2 by 1 multiplexer, I am going to have 2 inputs and 1 output. Right? Yes. So if I would like to generalize, can I take it as for one line? How many multiplexers are there of size 2 by 1? So there is no general meaning actually half multiplexer. So for the sake of your generality, I am trying to say for one line I need half multiplexer of size 2 by 1. Right? So for example, if I would like to have 8 lines, if I would like to have 8 lines, how many multiplexers are required of size 2 by 1? 8 lines, you require 8 by 2 multiplexers. Am I right? One line requires half multiplexer, 8 lines requires, basically it's simple mathematical question, right? Cross multiplication. So you require 8 by 2 multiplexers, meaning that you require here completely 4 multiplexers. But if you take 4 multiplexers, again 4 multiplexers having 4 outputs. So what you have to do again? So you are going to have again 4 lines. These 4 lines, how many half multiplexers are required? 4 by 2. So you are going to get 2 multiplexers. Again 2 multiplexers having 2 more outputs. So again 2 lines having 2 by 2 multiplexers are required. That means 1 multiplexer. can I stop the procedure here? Yes or no? So in order to construct 8 lines, 8 lines are for what? 8 by 1 mux. 8 by 1 mux. So I am going to get one output. That is because of having these 7 multiplexers. 4 plus 2 plus 1. So total 7 multiplexers are required of size 2 by 1. Of size 2 by 1, right? So if I am going to generalize this one, if I try to take some 16 by 1, multiplexer, so basically 16 lines are there. You require 16 by 2 multiplexers are required. You require 8 multiplexers, and then 8 by 2 multiplexers are required, that is 4. Then 4 by 2 multiplexers are required, that is 2. Then 2 by 2 multiplexers are required, that is 1. Right? So total in order to implement 16 by 1 multiplexer, how many multiplexers are required? 13 multiplexers of size 2 by 1. 15, huh? Okay, you are all active. So 8 4 12, 12 plus 2 14, 14 plus 1, 15 multiplexers are required of size 2 by 1. Right? So means, like for example, let me take, I would like to implement 32 by 1 mux using 4 by 1 mux. Now what I can do? 32 by 4, you are going to get 8 multiplexers of size 4 by 1. Next 8 by 4, you are going to get 2 multiplexers are required. Then you are going to get 2 by 4. 2 by 4 means what? 0 point something. But 0 point something is there, or you require compulsory 1. Meaning that you are going to get 0 point something, even I need to equate it to 1. So means if you are able to generalize, how I am going to do? I am going to start, like for example, if I take an m by 1 mux, I would like to implement with the help of n by 1 mux. What I am trying to do every time? Every time I am simply dividing m by n, and in the next level m by n square, next level n by n cube, next level m by n power 4, and so on, m by n power k. Am I right? So I can say that this would be m by n power k. So what is the value of k here? Number of levels. This is first level 4 gates are required, second level 2 gates are required, 2 multiplexers are required, third level 1 multiplexer is required. Right? So observe, if you want, you can able to observe. This is level 1, level 2 and level 3. Right? When you are going to stop this procedure? When this m by n power k value should be less than or equal to 1. Am I right? So I have to get the value either something 0 point something, or I can able to get the value 1. Get the value 1. So I can able to generalize. M should be less than or equal to n power k. If I am going to get the value, k should be greater than or equal to log m to the base n. Is it okay? I can take the logarithm on both sides and I can able to perform. So k should be greater than or equal to log m to the base n. So now you may get certain times 0 point something, right? 0 point something multiplexers are not possible. So I require compulsory, I have to use 1 multiplexer. That's why I made it as seal. So k value should be compulsory to be greater than or equal to log m to the base n. Is it okay? So I can say that if I am going to have m by 1 mux, if I would like to implement those m by 1 mux circuit boolean function in the form of n by 1 mux, I required how many levels? K should be greater than or equal to log m to the base n of size. Right? For example, if I would like to implement 8 by 1 mux using 2 by 1 mux, substitute the formula where k should be greater than or equal to log 8 to the base 2. Log 8 I can write as 2 cube. So I can write as k should be greater than or equal to 3 into log 2 base 2. So k should be greater than or equal to 3. So meaning that minimum 3 levels are required. That is what here we got. Right? Minimum 3 levels are required. Similarly, for example, if I would like to ask for to construct 32 by 1 mux using 4 by 1 mux, what we are going to do? So k should be greater than or equal to log 32 base 4 should be the seal. What might be the value? 4 square is 16, 4 cube is more than that value, right? Which is 4 power 2 point something. 4 power 2 point something, right? So means that k value should be 2 point some value. 2 point some value. So can I say that it should be seal, right? So that should be k should be greater than or equal to 3. Is it okay? Now how many? So we got to identify the levels, right? But how many? How many means what? Whatever data that you are going to get in each level, you have to make it addition. You have to make it addition, right? So how many levels are you going to get from level 1 to level 1 to what is the maximum level you are going to get? Log m to the base n. Log m to the base n. Now what might be the value here? M by n power k. Right? Meaning that for each and every level I have to make m by n power k value. Right? So if you are going to do that, so means summation of k equal to 1 to log m to the base n you are going to get m by n power k, right? So here I can simply observe here, right? If I am going to have how many 2 by 1 gates are required, simply 8 by 2 is one possibility, 8 by 2 is one possibility, and substitute in this here if you substitute, right? What might be the value of here k? You can able to simply replace this value with 3, right? K value 1 substitute, if you are going to substitute the k value 1, 8 by 2 power 1 is 8 by 2. Next k value 2, 8 by 2 square. K value 3, 8 by 2 cube. 8 by 2 cube, that's it, we can stop, right? So if you are going to solve this one, you will get the answer 4 plus 2 plus 1, 7. Are you going to get the actual answer or no? Similarly here also, something like 32 by 4 plus 32 by 4 square plus 32 by 4 cube. 32 by 4 cube, which should be seal, I think. Again, this also should be seal, right? So as I am saying that this should be seal, here also it should be seal. Why I am making it as seal? You have to make 32 by 64 is 0.5. That should make as 1. Right? So you will get here as 4 8 is 32, 16 2 is 32 plus 0.5. I make it as 1. So you will get 8 plus 2 plus 1. So total 11 4 by 1 mux are required in order to implement 32 by 1 mux. So this is important in the gate. This concept at the end what we discussed is important for the gate. Okay. Fine. So this is for today's class.